let's take a look at how to balance nuclear equations. We are going to work 3 different types of problems for 3 different nuclear reactions, for 3 different emissions, the alpha, the beta, and the positron emission. Okay, let's take the first reaction here. And I have kind of mixed it up to where we have 1 out of 3 missing, so that you can get an idea of how to work all of them. The important part about this is just treat it as just the same as a mathematical equation, where you see here that I have a top number and a bottom number. So this is the mass number and this is the atomic number. Treat the same as the top numbers, treat them as the mass numbers. The bottom numbers, treat them as the Z numbers, the atomic numbers, including the particles, the radioactive particles. The important thing to remember about nuclear reactions is that the sum of the left hand, whether it's talking about the mass number or the atomic number, but the sum of that has to equal the sum of the same numbers on the right-hand side, if you're looking at it. What do I mean by that? Well, if my mass number here is 9, then the sum of the mass numbers over here have to equal that same number. So if I have 9 for beryllium, 4 of those is the alpha particle. So the next element has to have the same, it has to have a mass number such that if I add it to the 4, it will give me 9, which means 9 minus 4 equals 5. So if you want to think of it as a mathematical equation in which 9, treat this sign as an equal, right? 9 is my mass number. This little arrow is the same as equal. And then I have 4 from the alpha plus an x, because I didn't know it. So solve for x. So my x is equal to 9 minus 4, which will be 5. Okay, let's do the same thing for the bottom number. This will be my Z, or atomic number. 4 has to equal, that's my equal sign, because I only have 1 on the left-hand side. I have 2 over on this side. So 4 has to equal 2 plus x. 2 plus x, which means that x has to equal 2. Therefore, this will be 2. Now, if I go to the periodic table, this number here, because it's the Z number, it should tell me the element. It should tell me the identity of the element. Element number 2 is helium. So this is my unknown element, and now I have solved it. Let's make sure and double check. My Z numbers, the bottom numbers have to be equal on the same side, on each side. Here I have 4, here I have 2 plus 2 equals 4. Let's look at the mass numbers, the numbers on top. 9 on one side, 4 plus 5 equals 9 on the other side, so I'm balanced. Make sure you use the correct notation. So here's our notation. If x is the element, then A is going to be the mass number, and Z is going to be my atomic number. So atomic number is at the bottom, mass number is at the top. Always, the top number is the largest, the bottom number is the smallest of the 2. Okay, now let's look at the second example. I have radium decaying to radon, and I want to figure out the particle. Same idea. My Z number, my atomic number on both sides, whether it's a sum, so this 88, because that's all I have on this side, has to equal the sum of the Z numbers on this side. Well, 86 plus what gives me 88? 86 plus 2. That means that I have to put a 2 here for the atomic number. Now let's look at the top number. 22 has to equal 218 plus x, because I don't have it. What do I add to 218 to get 222? I add 4. That means that this will be a 4. What particle has a mass of 4 and a z of 2? That's an alpha particle. And that is how I can figure out by what mode it decays. Okay, so now I've given you two different, here I needed to find the element. Here I was given the element and I found by what particle it decays. Here let's look at finding the original element, nucleus, knowing that it decayed by an alpha particle and it gave me this particular nucleus. Once again, the bottom numbers have to equal the bottom number here. So the sum of 2 plus 82 has to equal this one, x, because I don't know it. So x is equal to 2 plus 82, which means it should be 84. Now, I could go look this up because this is my z number. I can go look this up in the periodic table and find that 84 is element polonium. Okay, I found the identity of the element. And now I need to find its mass number, and I do that. X, because I don't know it, x has to equal 4 plus 204, which gives me 208. And that is the mass number for polonium. Okay, I have two more examples that I want to show you from the slide 13 in chapter 20 notes, and then we can go on to a different type of decay, but I'm going to pause while I erase this, and then we'll come back and do the other two examples, still with the alpha particle decay. Okay, let's take a look at the last two examples that deal with alpha decay and how to balance those nuclear reactions. Once again, if you draw a line right here in the middle, you have the top numbers and you have the bottom numbers. The numbers on one side have to equal the sum of the numbers on the other side, whether they're the top or the bottom. So let's start with the bottom number. This 91 has to equal 2 plus x, because I don't know this number. So if I write it as an equation, 91 has to equal 2 plus x. Therefore, my x has to equal 91 minus 2, which is 89. 89. Now, if I were to look this up in the periodic table, I would find that this is actinium. This is proactinium, this is actinium, because it's element number 89. Now let's take a look at its mass number. Once again, the top number, which is 231, has to equal 4 plus x, which means x is equal to 231 minus 4, 227. Okay, so that is my mystery element that proactinium decays into by emitting an alpha particle. Let's look at the last example here. Once again, the bottom numbers have to equal on both sides. The top numbers have to equal on both sides. Let's start with the bottom. So 79 has to equal 2 plus x. So if I take 79 and then subtract 2, I get 77, which is element number 77. It's iridium. And then 185 minus 4 gives me 181, which is the mass number for this particular element. Thus, I have balanced these nuclear reactions. 79 on this side, 77 plus 2 is 79, which means I have balanced my Z, my atomic numbers. Here I have 185. 4 plus 181 gives me 185. So I have 185 on both sides, which tells me that I have calculated this correctly. I am going to erase this, and then we will move on into learning how to do beta decay.